For you guys to help me, I need you to take out your tablets and open up your OneNote and go to your shared OneNote folder. While you guys are doing that, I'm going to explain to you what's going on and why we're about to do this. So over the last few weeks, I've been running into a lot of resource issues with my computer because with the shared OneNote notebooks that you guys have, apparently how this works is my machine creates a backup for every single thing that you guys have in your notebook. So I have like a 50 gig block of these backup temp files chewing up like all of my disk space on my computer because of all of the things that we have in our shared OneNote notebook. So what I'm going to ask you to do is in the shared section, we're only going to keep the things that are like not yet graded. So anything else we're going to move into our own private section of OneNote. And as you do homework and I do homework checks and they get checked in, I'm going to ask that you make sure that you move those out of that shared section into your own private section. Kind of each week after I've done the homework checks. I know that's kind of a hassle, but it feels easier than revising a whole new system and like getting used to a whole new like turn-in system rather than just doing this. So let me describe to you what we're going to do here. And I'll use, I'm going to use Amanda as an example. So Amanda's got her stuff in 4 different tabs, one for each chapter, right? So the only things that Amanda, we want to leave in here is the things in chapter 4 that haven't yet been graded. And I think for Amanda, that's nothing. So we'd want to move all of these things into another area of the OneNote that's not a shared notebook. So there's a couple of ways you could do this. So you could start by moving over and clicking on the first thing on your list of pages. Press and hold down the Shift button, and then click on the last thing. So now all of these pages are highlighted, right? Everybody see that? If I right-click in that highlighted area, I can pick the Cut option, and then I can back out to like my own personal notebook, and then make a tab in there for this class and paste it into the Pages section. That's probably the easiest thing to do. You could move a whole tab somewhere if you have everything as a tab. If you know how to do that, you could do that also. Okay? So like in your drop down, you should have a notebook that has just your name on it that's not shared with anyone. You're going to move it somewhere in there. So if you just want to delete the things that I've checked already, you're free to do that. Like, it's your work. You can do with it as you wish. I just can't have like that much space on my machine chewed up from all of these backup files and temp files and stuff that the computer's creating. Yeah, if you want to keep the unit circle in there, that's reasonable. Or the active things that you're using in chapter 4, like if you have the problem list, you could keep that.
Mr. Cool, can you explain how to do it again?
Sure.
Do you like press shift and then like the last one, or is that like?
So you have to. So Dan, if we go and look at yours. So I'll go in the homework tab here. And I'm going to click on the first one, press and hold down Shift, and then click on the last one and give it a second. And they all highlight. And then you can just right click and pick Cut. and it'll cut all those pages and you can paste them somewhere else.
Okay.
That's what you needed?
Yeah, thank you.
You're welcome. You're in the Wimpy app and not the full version?
No, I'm in. I have nothing. Oh,
I don't think yours is it's like, I don't know.
It's not clear. I'll figure it out.
I don't know.
Yeah, I don't want to. Okay, well. Really making me oh, I figured it out.
So again, we're going to wait, give everybody a chance to kind of get things moved. If you have questions or you can't figure something out, you can always bring your tablet up and I can help you. Or if one of your neighbors has figured things out, feel free to ask them for help. No big deal. All we're doing is just moving some files around on our OneNote. Right? Easy there, big guy. We need to get that upset about it. It's among there's several things that are kind of going on that are affecting the performance, but this is not an insignificant one. On these A days where I teach 4 times and I make 4 videos, that at points are still like, I'll have 2 or 3 of them still on my computer that might be, 8 to 10 gigs each. It's like there's just no space left on the computer, and yes, it just makes it's a nightmare. Yes, yeah. So this will be a big help.
I should have moved, say that.
So again, Megan, this stuff will all catch up here eventually. Yeah, it might be a sync issue on your end.
I'm trying to sync it right now.
Yeah, I can see that my tablet is trying to sync right now, so it's fine.
Everything should be gone.
Yeah, you have to understand too that there's like 30 changes happening on my end right now, so like it's gonna take its time trying to do this. Like if I go and I look at some of these others, like Amanda, yours is still.
Yeah, I moved.
Yeah, I believe all of this has happened. Is anybody still working on moving things? Okay. So I'm gonna leave this for now. I'm gonna let it kind of figure things out. We'll revisit this later on, and I can check and make sure that individual people have gotten things sorted out over the next week or so. But even if like half of you guys got that figured out today, that'll be a big help moving forward. And if something's not quite right, I'll come back and catch you guys one on one. But it sounds like everybody's tried to do this. And I'm hoping between, everybody in here that will be relatively successful figuring that out, as you guys are quite smart. So as a whole, we can certainly have enough people that know what's going on to kind of get that taken care of. The plan today is we're going to talk all about 4.2. because there's not much to 4.2. And then we're going to talk about 4.3. I just have to find the rest of my notes here. There we go. So 4.2 is a pretty... What's going on?
It's just for one of the chapters, like one of the tabs I have, it just says it's not.
Okay, so just...
Maybe it's like in the process of moving.
Yeah, it's probably what's going on. You're welcome.
Nice then.
So in 4.2, this section is about problem solving. So basically what we're talking about is story problems here. And there's really just two key pieces of vocab here. Nope. I mean 4.2. We haven't done 4.2 yet. Everything that we had done to this point was just 4.1. No. Well, you did worksheet 2.
Oh, okay.
But worksheet 1, 2, and 4 are all coming from section 1.
4.2 really like worksheet.
Yes, worksheet 3 is a 4.2 one. Yes. So there's two pieces of vocab here. These are the two pieces of vocab here that are going to be important. Is angle of elevation and then angle of depression. And when I describe angle of elevation, I'm not going to do this in words. I'm just going to do it with a picture. So here's some person, right? And they're looking straight ahead. That's their line of sight. And they see up in the air like a balloon or something. Angle here is our angle of elevation. So the angle of elevation is always measured from like the observer to the object. Keep in mind that like this guy right here is not the same as the angle of elevation. What page am I on in the notes? 6. So I'm looking at the lessons, page 6. Is that what you're asking? Okay. So angle of elevation is like the angle that you have to crane your neck to look up at something. Everybody's okay with that notion? Angle of depression is like the opposite idea. So let's say we're standing up on the top of a cliff here, and we're waving to our friend down below. Our angle of depression is going to be this angle made when we look down at someone or something. So let's do a couple of story problem examples where we take advantage of this, or apply this. Okie doke. I'm just waiting for this file to open so I don't have to write down all these words, that I can just copy and paste them in. It's just taking forever for whatever reason. I wonder if I can just do this. I'm sick of waiting. Where is that snipping tool? Oh my God. Hi guys. This is the issues that I've been running into for weeks. And now part of this is my own fault for having you guys all change that OneNote stuff right now. I probably should have done it in at the end of the hour or whatever. Because now OneNote is fighting, trying to catch up on all the changes that just happened. But my whole system is wanting to go and decide to not want to do anything. The top of the spire to measure 66 degrees. How tall is the building? So let's draw a picture. There's Christy. Here's the building. There's the spire on the top. Look at the great art student I am. So make our triangle here. This is her line of sight. And this is her angle of elevation. So this is the 66 degrees. We know that buildings, when properly built, are going to stand at the right angle. No offense, Italians. That's a Leaning Tower of Pisa joke. And we know that she's 200 feet away. And we want to know how tall the building is. So basically, we just need to solve for x in this triangle. Pretty easy, right? How do I do that? Tan of 66 is equal to opposite over adjacent. So x is equal to 200 times tan 66. Before I type this into my calculator, what do I have to be careful about? Yeah, I gotta make sure I'm in degree mode. Who's gonna forget to do this on the test, turning back and forth between their calculator modes? Ooh, it's gonna be a tricky one. 449.2. I'm warning you right now because every year somebody forgets to do it. It's like, oh, that's a mode problem. Everybody feel okay with that example? The hardest part is getting the setup down, right? Once the setup is set, solving the triangle is usually pretty easy. Let's look at another example. It says Jane is climbing, or has climbed a tree, is now looking down at her friend Mary. Jane has climbed 17 feet high in the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? Okay. So, here's Mary's line of sight. There's looking down at her friend. So it says it's an angle of depression, so we know it's this angle that's 49 degrees. And we know that people typically are going to be standing perpendicular to the ground, unless they have like some odd situation and they have like one leg shorter than the other. They're in a hole, standing with one foot in a hole or something, you know, or they're leaning at an angle. But we'll assume that Mary is not that. And we know that Jane is 17 feet up in the air. And we're looking for how far is Mary from the tree. Standing from the base of the tree. Now notice that this side here would be the same if this is the 49 degree angle and this is the 17, and that's the x. It's still the same triangle, right? That from geometry, since what I drew is a rectangle, and we know that the diagonal of a rectangle makes two congruent triangles. You guys remember that? Vaguely, maybe. Enough to be like, oh yeah, when you do that, I know it. That's true. It makes sense. Anyway, so now what do? We're going to solve this. So we can say that tangent of 49 is equal to opposite over adjacent. So to solve, I cross multiply, so I get x times tan 49 equals 17. And then I divide both sides by tan 49 to get my x by itself. And that should be about 14.7. You know how we can tell we want to be in degrees? In the problem, the angle measure is given to us in degrees. So it's told us in the problem that you should be in degree mode. Is that okay with everybody? This one feels, again, the solving part probably pretty easy, right? The only tricky part is getting the picture correct with the things in the right places. But that's mostly just like a reading comprehension thing, right? If you can read the problem and get the, understand what the picture needs to look like, it's pretty easy to do from. One. Claude and Simone are riding bicycles in Paris. At one point, they look up, and the measure of elevation to the Eiffel Tower is 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? There's my very great Eiffel Tower. So this is our first observation point. And we go a little bit closer. And this is our second observation point. Everybody's okay with that? And we know the distance between them was 100 meters. Everybody so far so good. How many right triangles do you guys see? I see two. I see one that looks like this. And I see one that looks like this. Everybody agree with that? In each of these two triangles, this side is H. That's going to be the same, right? Because they're both looking up to the same top of the same Eiffel Tower. Everybody agree with that? So let's call this side X, since we don't know what that is. What should we call this side? 100 plus X. Everybody agree with that? Okay. How many variables do we see? 2, right? In order to solve 2 variables, what do we need? How about a system of 2 equations? Everybody agree with that? So for this triangle, I can say that tan 32 is equal to opposite over adjacent. And for this triangle, I can say tan 37.5 is equal to opposite. If I cross multiply, I can say that H, and here I can say H is equal to X times tan 37.5. Now we have an option here. We can either try to solve this equation for X and then use that answer to find H, or we can try to solve H directly by doing like a substitution for the X. It doesn't really matter. I'm going to tell you that, as silly as it seems, I think it's going to be easier to find the value for X and then plug that back in to find H, rather than try to separate the X so that we can like plug that back in, and you're going to end up with some yucky fractions and like kind of a crummy situation. Is everybody okay with that plan? And the reason I say that is because each of these we've already separated the H. So via substitution, I can say this. Everybody good with that? Remember in Algebra 3-4 last year, you solved systems using substitution or elimination? I just use substitution there. Since they're both equal to h, I can set them equal to each other. So now I'm just going to get the x's onto one side. So I'll distribute that tan 32 through. Remember that tan 32 is just a number. You could turn it into a decimal at any point here and just deal with the decimal. I'm going to leave it as tan 32 and just so I don't have to use my calculator one time. X there. So now what I'm going to do is I'm going to subtract this x times tan 32 to the other side. Notice that x tan 37.5 and x tan 32 both have an x in common. So I'm going to factor that x off. Oops, that's a minus. And then I'm going to divide by tan 37.5 minus tan 32. And that's what I'm going to type into my calculator. Are we okay with the algebra that we did there? So I'm going to do this using the fraction command so that I have less of a chance of screwing up a set of parentheses or something in this. So I'll do 100 times tan 32, and then I'll do tan 37.5 minus tan 32. So I get x is 438.6. And plug it back into one of my two equations. For the sake of argument, I'm going to use this one because it seems like it's a little bit simpler. I think that was the tan 32. Let me double check real quick. Nope. Good thing I did because that's the tan 37.5. Okay. So I'm just going to steal this answer from my calculator and multiply it by tan 37.5. So 336.6. Yes. Are we, any questions about this example? Was okay? So that's it for 4.2. 4.2 is basically just going to be, the whole point of the notes was just to get used to describing things as angles of elevation or angles of depression and be able to draw the picture. If you're able to draw the picture, the algebra would probably be no worse than this problem here. For the most part, it'd be easy like the previous two problems. And the only thing that made this difficult was having the system to solve. But even that wasn't so bad, right? I hope, anyways. Yes. Sure. Oh my goodness, OneNote. Is that good, Delaney? Okay. Next, we're going to talk about section 4.3. In section 4.3, we're going to start dealing with the V word, vectors. Let's go. It's exciting. Delaney, are you good? Okay. I'm just checking. It's raining outside, guys. Oh, good. Thank you. So we're going to talk here about applications of trig functions, that is vectors. This is our topic for 4.3. And the first thing that we need to do is we need to define the way that we measure angles when doing navigation. So the course or bearing of an object is given as the object's line of travel measured from due north, which is really unfortunate why they've chosen to describe their navigation in this fashion, because it's not the same as our angle of rotation definition, right? By drawing the XY axis, and I'm going to label this like I would the compass rose. Like. Everybody's okay with that idea? What's the equivalent angle of rotation for this? That would be this angle, right? What's that measure? 18 degrees. So we can say that a bearing equivalent to rotation, thing involving a bearing, most of these directional problems involving vectors, because when we use sine, cosine, and tangent, we have to make sure that we're using our angles of rotation. But when we're using but the problems are going to be given to us in bearings, right? So we're going to have to make sure that we're taking some care to convert from bearings to angles of rotation here. Leah. Well, because each quadrant is 90 degrees. So if I start at north and I go 72 degrees, does that? Yeah. Sophia? Of course. Do we feel okay there? Let's do another, yes? This is an important skill that, while not difficult, let's say if we can't do this, it creates big problems. So our bearing is going to start at north and go clockwise. 90 degrees is to here. And then we have 7, so it's going to be over here somewhere. Everybody agree with that? Now to get my bearing, or get my angle of rotation, that's 90, that's 180, that's 270, and then this little piece more. How much is that little piece? Well, this is 90, 94. So this little piece has to be 16, right? Everybody agree with that? So this then has to be 286. Leah. To get the 16?
Yeah.
Okay. For this problem, yes.
But like not always.
Not always. I mean, if we went to the previous problem, 80 minus 72, you wouldn't have gotten the correct
Right,
answer.
but when you do 90, like that's the.
Okay. That's fine. That'll give you this little leftover piece.
Yeah.
And that may or may not be the angle of rotation. It'll be related to the angle of rotation, but it won't necessarily be equal to it, like we saw in the first example. Right? The second example, the angle of rotation is 286.
Oh, okay.
You know what I mean? So that other little leftover piece is always going to be useful to us, but it's not necessarily just the answer. Does that feel okay?
Yeah.
Okay. And these are good questions, right? Like trying to figure out how am I going to actually do this in a way that makes sense to me. Important question, because there's often more than one way to do that. Do we feel okay about this process? We get the gist of it? Yes. That's a 74 on there. Yeah, you can just keep it. I believe you. Bye, Brooke. Okay, so let's do an example here. Discuss the process as we do this example. So rather than outlining the whole process, I think it'll be easier to deal with doing it while we're doing an example. Is that okay with you guys?
So the bearing of the second example.
No, the bearing was given to us was the 164. That was the 286.
Oh.
That was the 270 plus the 16 at the end. So for whatever reason, it's OneNote is being uncooperative for me again. All I tried to do is paste in some text. Grace. Of course. This is a good time to go because apparently we're just... Oh, there it finally came in. Look at that. 10 minutes later. All right. So a boat leaves a port. This should probably be at an average of 40 knots. That's just a speed. That's nautical miles per hour. Traveling for 2 hours on a course of 215 degrees. Then the boat turns to a bearing of 172 degrees and travels at 55 knots for 3 hours. What is the distance and bearing of the boat relative to its starting position? So, let's talk about the procedure that we're going to do. So, when I read this problem, I read two separate vectors. I read the first turn as vector 1, as vector 2. Ben. Sure, that's okay. It's an important question. So a vector is a quantity. All vector quantities have two parts to them. They have a direction and they have a magnitude. So for example, like you hit a baseball at such and such angle with such and such force, that's a vector quantity. As a force, that's a scalar, just a number, and a direction, it's at some kind of an angle. Okay with that? Now we can resolve all vector quantities into a couple different representations. One, the representation for us that's going to be most useful is into a component form. So if I have some magnitude in some direction, like some length at some angle, I can turn that into basically like an x component and a y component. That's what I'm going to want to do here, because to add the two vectors, I can just add their components. And then I can take that resulting vector, calculate its magnitude and direction, and report my answer. So I'm going to call, so its magnitude is 40 knots. Oh, sorry. Miles. How did I get that? 40 knots. At 215 degrees. Okay. So let's draw that picture. So here's 180, and then like 35 more puts me down here. Everybody agree with that? Of course. So, what I'm going to do is I'm going to now resolve this into, or transform that bearing into an angle of rotation. So here's 90, 90, and this piece must be 55, right? To make 90 down below. Is everybody okay with how I got the 55? 35 plus 55 gives me 90. So my angle of rotation is 235. So the x component of vector 1 is just going to be 80 times cosine 235. And my y component is going to be 80 times sine 235. Ben? So basically I'm looking for this coordinates. So this is like x comma y, or cosine comma sine. Yeah, so vector 1's x component and vector 1's y component. And the way we usually, and we'll write it like an ordered pair. And again, this is like 80 was our magnitude, and this is our direction. And we just resolve that into a different representation. So that 80 cosine 235 comma 80 sine 235 is just a different representation for that same information. We like that other representation better because it allows us to add the two vectors directly. Vector 2 has a magnitude of 165. That's the 55 knots times 3 hours. And its bearing is 162. So I'm going to do the same thing. And I'm going to draw my bearing. So 162 degrees is down here. So that was 90 to there. So this is got to be 72 more. And then my angle of rotation is 90, 90, 90, and 18, because 72 plus 18 is 90 degrees. Any questions? That's my angle of rotation. Sorry. Let me write it this way. That's what I did before. I'm just converting the bearing that was given to me, the 162 degrees, into an angle of rotation so I can use sine, cosine, or tangent on it. I can't do sine, cosine, or tangent of a bearing because those functions aren't defined on a bearing. They're defined on an angle of rotation. Is that what you're asking? At a bearing of 162 degrees. Yep. Okay. I'm confused on what your question is, I think. It's the complement of 72. It's the complementary angle to 72 because 18 and 72 make 90. Because we know one full quadrant is 90 degrees. Is that okay? So then I can calculate the x and y components for vector 2 the same way we did before. So it's the magnitude times cosine of my angle of rotation for x, and 165 times sine angle of rotation. Again, for that vector. So where this, whatever this boat is going to end up is going to be the sum of these two vectors, right? Because it does this, and then it keeps going and does that. So it's going to just be the sum of these two vectors. So I'm going to call, actually I'm just going to call the resultant V, and I'm just going to write the word result. So the x component is going to be 80 cosine of 235, sine of 8. And the y component is going to be 80, 235, plus 165 sine 2. I'm going to go to my calculator and type those in. So that's 5.10. And then negative 222.5. So V is the component. Then that. Yes, Elizabeth. Of course. And we're almost home now, guys. We got the important information that we need. So what does this component form tell me? Well, it tells me that the final location of the boat at this point. Everybody okay with that idea? So I need to figure out the length of this line, or the magnitude of the vector. Well, that's easy. It's basically just the Pythagorean. Because I have a right triangle inherently anytime I draw something on the xy axis, because I have the x side, the y side, and then that length is just the hypotenuse. You know what I'm saying? Right? So this is like my vx, and that's like my vy. So the magnitude is just the Pythagorean theorem. So when I do that, I get 222.5. That's my resultant magnitude. Everybody okay there? Note that it is not actually a number as the y value. They're just very, very close. And the reason that happened is because the x was so small relative to it. You know what I'm saying, guys? So don't let that confuse you, because it does look initially kind of confusing. Everybody's okay with that idea? Ben? Yes. Yep. So it'll always be the same every time. Once you have your component form, you take the x component squared plus the y component squared, square rooted, will give you the magnitude every single time. That's one of the beauties of this component form, is it's really easy to get back to a magnitude and direction. The other part that we're looking for is a bearing. So we're looking for this angle, right? I'm going to call this angle B for bearing. So that angle is going to be 90 plus this little piece here that I'll call phi, where phi is that angle between the hypotenuse and the x-axis, which is exactly what we just got done finding all the time when we did those problems on worksheet 2. So phi is just going to be the inverse tangent of the absolute value of over Vx. Oops. I guess I need to do that. So that is 88.7. So this value then is about 178.7 degrees is my bearing. Yes, that's what it asked, right? What is the distance? That's the magnitude. And the bearing of the boat relative to its starting position at the port. So we're going to stop here because there's 10 minutes left and I don't want to get any further into this, but we'll take some questions here before we finish to make sure everybody's clear on what we just did. Leah. Of course. Okay. So to sum up what we should be working on next time, let's do from the homework. Well, let's go to 31 for next time. And if you want to start on worksheet 2, you could also do that. Next time in class, we're going to we'll start by answering questions. We'll do another vector example or two, depending on what we do in questions, what you guys feel like you need. And then we'll work on worksheet, is it 6 or 7? I have to look here real quick. 7. So if you need to get ahead or if you weren't going to be here or whatever else, that's kind of the plan. Chris. Oh, I'm sorry, 3. Thank you, Chris. So worksheet 3 is just story problems, similar to what we did at the beginning of class. Okay? So again, these problems, worksheet 3, do enough of it so you get like an idea of whether you know what you're doing or not. Don't feel like you need to do the whole thing. But do enough so that when we come back next time, we can talk about what do we still need help with and what don't we need help with. So we can kind of be productive in that next class. Because we don't really have any more content. This is basically it for this week. We're going to do another work day to kind of solidify these ideas, particularly the vector thing is not trivial, right? That's not super duper easy and intuitive right off the bat. So it's okay if we need to take a day and like kind of stumble through that and do some more example. That's perfectly fine. That's kind of the expectation. One example on something like that is probably not adequate. So that's okay. I did assign some of these problems on 19 through 31 are vector problems. Try a couple of them. Some of the odd ones where you can check the answer would probably be the best ones to do to get a feel for like how close are you to being able to do this, so that when we come back next time we can do some more targeted examples to get you going in the right direction. Delaney?
So basically, the class on Thursday is going to be vector examples and then a work day for worksheets.
Yes. Yeah. So worksheet 3 should be something you can do. That's like those problems at the beginning of class. Should be relatively straightforward if you can get the picture drawn correctly. The worst case scenarios you end up with a system to solve, but again, those aren't so bad. But that's it, yeah, for today, and really kind of closing out this chapter. So we'll close out the chapter this week and then looking at review and testing next week. Amanda.